Today we're going to do a quick add-on to our extra credit for parallel and perpendicular lines. Y'all did really well with this in class. I just want to give you a brief little review to review before your test. First of all, parallel lines in general, this is the notation for parallel lines, and parallel lines go on forever and never ever touch each other. They're equidistant from each other. Perpendicular lines cross each other and they form a 90-degree angle, and that's the symbol for perpendicular. When we're talking about the slope of two lines, it's not going to be one line, it's going to be two lines. You want to know if the lines are parallel, if the lines are perpendicular, and be able to write a parallel or perpendicular line. So the slope, if we're talking about of a parallel line, the two lines have the same slope. When I'm talking about perpendicular lines, they have what we call a negative reciprocal, which some of you called an inverse. Same thing. That means, I'm going to kind of create a little chart here for you, just like we did in our notes. If my slope was 2 of my one line, the parallel slope is the same line, the slope would still be 2. If I asked you for the perpendicular slope, it's the negative of that and its reciprocal, which is 1/2. So it's negative 1/2. If our slope was negative 2/3, the parallel slope exactly the same in our second line. If I said the lines were perpendicular, they're going to be the negative of this reciprocal, which ends up then being a positive 3/2, because a negative and a negative make a positive. If my slope was 0, parallel would be 0, but we know that a 0 slope is going to be this horizontal line, so the vertical line would be its perpendicular slope, which then would have a vux, which is undefined. Now, with this information, what the heart of our lesson is going to tell us is that if I gave you a line and I said I wanted to write an equation of a line that is parallel to this line, so on a parallel line that goes through the point 1, 2, how am I going to do it? Well, first of all, I have to be able to identify the slope in this line. This slope right here is 2. So its parallel slope then is the same, so therefore it is also 2. I'm having it go through this point, and I'm using this slope. Exactly. That's when I pull out my old favorite point slope form. Point slope form says y minus y1 equals slope x minus x1. Knowing that this is x1, this is y1, and this is my slope. Now all I'm doing is plugging that into this point slope form and writing my new equation. So y minus 2, slope x minus 1. Now to solve this, I'm going to distribute. And because it just asks us for the line that is parallel to this, I can go ahead then and just keep it in slope-intercept form and simplify. Now, because I know that the line is parallel, I should note that if this is 2 and that's 2, I'm on a good cause there. Let's look at one more. Okay, try this one on your own. I'm going to work it. While you're working it, pause the video to help you out. There's the equation of the line that is parallel through the point -2, 4. Now I want to find the perpendicular line going through point 1, 2 that is perpendicular to this equation here. So the first thing, again, I'm going to identify the slope. I'm going to identify its perpendicular slope. So it's a negative reciprocal. So here's my slope. Here's my point. And again, I start with my point slope form. Oops, that's a Y, sorry. And I gotta think here for a second. 2 is 6/3 minus 4/3 is 2/3 positive. There's the equation of my line that is perpendicular to that slope. I know this was a short little add-on. That is fine. You all have a great day, and don't forget to do the other video as well.